ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజీలో చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్లో కూర్చొని చదువుకున్నంత సీరియస్గా చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ని పరీక్షించుకున్న కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
Hello my dear students, welcome back to this video, and here we are going to discuss about Kirchhoff's laws, same under electric current only this chapter. And Kirchhoff's laws, these are applicable to any DC circuit where batteries are connected, there this is applicable. In this Kirchhoff's laws, there are two laws are there. One is junction law. First one is junction law. We see this is junction law, and the second one is what? There we can take. One is junction law, another one is loop law. This is loop law. Junction law and loop law. We see that what is junction law and what is the loop law, and among these all which is better we are going to see, or both are comfortable, both are useful or not. These are we are going to study now. Let us see now. There are two simple rules are there in this Kirchhoff's laws. The first one is what? The junction. And junction means what? It is a point where 3 or more conducting wires meet. Here we can take, here we are taking that 2-3 wires they are meeting here. This is, let us take it as I1, I2, I3. From there, 2 other connections we are taking. Let us take them as I4 and I5. We call this point where all these lines are meeting, we call this as what? As junction, J. This is the junction we are taking at any junction point in a circuit where the current can divide. Sum of the currents into the junction is equal to sum of the currents leaving the junction. Leaving the junction means what? There, that is what is that we are taking in this circuit, in any circuit, what we are taking? Sum of all the currents, sum of entering currents is equal to sum of leaving currents. What we can take now? I1 plus I2 plus I3 is equal to I4 plus I5. I1 plus I2 plus I3 is equal to I4 plus I5. This is based on conservation of charge. What is the basis for this? Conservation of charge. This you have to remember, Nana. This is that in the junction law, there we have to take that the basis for this is what conservation of charge. Means charge cannot be created, charge cannot be destroyed. How much charge is entering into the junction, that much total charge will leave the junction. That is junction law. When we come to this part, the loop law, what about this loop law, what we can study here? This is that algebraic sum of the increases and increase in the potential difference across various components of the circuit in a closed loop must be 0. Algebraic sum of the increasing and decreasing in potential difference across various components. That is what we are taking it as what totally it is 0 whenever it is a loop is concerned. When the loop is concerned, let us imagine that one circuit loop in the potential difference between the 2 points at the beginning of the loop has a certain value. We can take that any one loop so that you can understand what I am explaining you. This is that a resistor, and here there we have to take, there is a battery source is there. Here we have to connect like this. This is that R. Let us take it as R only because we have only one resistor. Let us take it as one R only. What happens to this now? Let us take this as what? A, B, C, D.
Students, my name is Vishal Sharma and I did my BTech from IIT Kanpur in Electrical Engineering. I have an experience of more than 12 years in preparing IIT JEE aspirants for this examination. Under me already more than 100 students have cracked this IIT JEE examination. Right now I am associated with K. Venkana classes. Now K. Venkana classes, for the first time in Hyderabad, it has brought your top Delhi, IIT and NITN faculties. Now what are you waiting for? Come and join us and realize your dream of getting into IITs.
Here what happened, this is a positive, how much current is entering into this, the same current will leave. That already we have seen in that junction law. There in the loop law, what happens? Here this is that voltage whatever is applied. Here this is that voltage drop IR. We are taking it as IR. There we can take it as what? Algebraic sum. There we are writing in any circuit sum of entering current is equal to sum of leaving current. But here what we are taking that in any loop of circuit, any loop of the circuit, what we can write here? Algebraic sum. What is the meaning of algebraic sum? Algebraic sum means including plus and minus signs. Positive can be added and positive negative also can be added. Whenever we write 5 minus 3, we can write it as 5 plus of minus 3. Means to 5 we are adding minus of 3. That's why we are writing it as what? Algebraic sum. In this algebraic sum of increasing and decreasing of the potential differences across various components in a circuit, sum of potential differences across circuit is what? Is 0. Means here how much voltage we are applying. Here there we can take that as what? Current flowing through that we are writing it is, this is supplying plus, and there whenever we take it as minus IR, this is equal to 0. Because it is a drop, it is voltage drop, this is voltage supply. That's why V minus IR is equal to 0. Means actually what we have to get? V plus of minus IR is equal to 0. This plus into minus only we are writing it as minus. V minus IR is equal to 0. But for this kind of the loop, circuit loop connection and all these, there is certain kind of the sign convention is there. Such kind of the sign convention for the loop will use. What is that sign convention? Be careful while observing the sign convention. This sign convention. This sign convention in this Kirchhoff's laws, there what we can take, what is to be considered different sign convention. The first point, listen very carefully. First related to EMF only, means near the voltage source. Whenever we are taking that loop direction, here I will tell you one more thing to understand better. This is a loop direction whatever we use. We can use in any direction, not only in this clockwise, we can use that in anti-clockwise also. This is loop direction and this is what the current direction. Then in the sign convention, we are going to see such kind of the things only. There too, for your better understanding, I will use one more circuit for the same. There we are writing this as the resistances. I am sorry. And here, and there we are taking. This is that the current direction, and it is minus and plus. Here we are taking it is R1 and R2. Here I is there. The I only throughout this is I. Here we have EMF. Whenever while taking that EMF, the loop direction, we are taking that loop direction, let us indicate it as A, B, C, D. A, B, C, D. Whatever we write in this, what is it loop we are taking here in the sign convention? Loop A, B, C, D, A. Again it has to come back to A. Whenever the loop direction, this loop direction is related to this here EMF, this EMF. Whenever the loop, this is that loop direction. Whenever it is passing from plus to minus, we have to write this EMF as what? As suppose this voltage, let us take this voltage as 10 volts. Here what we have to write, this is traveling from plus to minus. There we have to write it as what? This value as minus 10 volts. Suppose the same EMF direction, loop direction is reversed. Suppose if it is like this, same, here it is 10 volts only. Then what we have to write, it is traveling from minus to plus. Final terminal whatever is there, that terminal value here we have to write. That is about EMF or the PD, potential difference. When we come to that, the resistances in the direction, second one is the load or resistance. Resistances. Across these, what we write generally, we have to write it as PDs, potential differences. When through any resistor, here this is the current direction, this is I direction. Suppose this is the loop direction. There we have to remember that loop direction. What is the loop direction? The same direction. When loop direction and current direction both are same, we have to write this as resistance. How much we have taken here? Simply R will let us write. There we have to write when both are same, loop and same. There we have to write it as what? IR minus IR minus IR. This is to be considered as negative. When through the same resistor, when current direction is like this here, current direction like this, but loop direction is in opposite. This is loop direction. Loop direction means don't get confusion. This is loop direction. See that how is the loop direction? Current direction is one direction like this, and loop direction is in another direction. Here also loop direction is in one direction, current direction is like that. At that time we have to take this product as what? This is I. This we have to write it as plus IR. Plus IR. This is the sign convention what we have to take. If it is against the direction of electric current through the resistor, it is to be positive. Both are opposite mean positive, both are same direction means negative. In this case, EMF, when the loop direction is from positive to negative, finally whatever that sign is there, that value here we have to write. Here finally whatever the plus is there, if we have to write it as plus only. This is the way what we have to connect, what we have to observe in the sign convention. Basing on this sign convention only, we are going to study about what the different kind of the circuit diagrams we are going to study. Different kind of the circuit diagrams and different kind of the combination of the resistances. About those all we are going to see in our next video. There, this video, whatever we take that, here in this video, these Kirchhoff's laws, whatever we studied, those are very, very, very important. Generally, the students get the fear here only. ikkada పిల్లలందరూ కూడా ఎక్కడ స్టూడెంట్స్ అంతా కూడా ఇక్కడ భయపడుతూ ఉంటారు. సర్క్యూట్ని చూడగానే భయం వచ్చేస్తుంది. ఎందుకు భయము? అన్నక రూల్స్ మనకు తెలిస్తే చాలు కదా. మీలో చాలామంది ఎన్ని రూల్స్ పెట్టినా బైక్ డ్రైవ్ అనేది చేసేస్తాం, భయం అనిపించదు కదా. ఎందుకని అని అంటే, ఇఫ్ యూ సిట్ ఆన్ దట్ విల్ ఎంజాయ్ ద డ్రైవ్. అంటే మిమ్మల్ని అందరినీ కూడా 18 years తక్కువ రాగానే బైక్ డ్రైవ్ చేయమని అర్థం కాదు. వద్దు అన్న వాటిని మనం చాలా బాగా చేస్తాం కదా, కంపల్సరీ చేస్తాం కదా. అట్లా చేస్తే అది ఒక థ్రిల్గా ఉంటుంది మనకి. అయితే ఇక్కడ కూడా ఆ థ్రిల్ అనేది దీంట్లో కూడా వస్తుంది. మనకి ఏది రాదో, ఏది భయమో దాన్ని పట్టుకొని చేయాలి, మనం దాన్నే చేయాలి. మనకి ఇది రాదు, మనం ఏం చేస్తాం? దీన్ని వదిలేస్తామా? అస్సలు వదలకూడదు. అలాంటి దాన్ని పట్టుకొని ఈ రూల్స్ మనం ఫాలో అయితే కదా, మనకు రూల్సే కదా ఆ బైక్ డ్రైవ్ చేయాలంటే. ఏది ఏం చేయాలి, ఎట్లకి చేయాలి, ఇవన్నీ కూడా ఎన్ని చేస్తాం మనము. ఫోన్లో ఎన్ని గేమ్స్ ఆడతాం, అన్నిటికీ రూల్స్ ఉంటాయి, అన్ని రూల్స్ మనం ఒబే చేస్తాం. కానీ స్టడీస్ దగ్గరికి వచ్చేసరికి రూల్ అనగానే భయపడతాం. ఎందుకు? మనమే ఆలోచించుకోవాలి. ఎందుకు భయము? మనకి కొన్ని రూల్స్ ఉన్నాయి. ఇవన్నీ కూడా సైన్ కన్వెన్షన్లో వచ్చే రూల్సే ఇవన్నీ. ఈ రూల్స్ కనుక మనం సరిగా మనం గుర్తుంచుకుంటే, ఇలాంటి రూల్స్ అన్నీ మనకి ఈజీ, ఈ సర్క్యూట్స్ అన్నీ కూడా చాలా ఈజీగా సాల్వ్ చేసేస్తాం. మీరు కొన్ని 2-3 ప్రాబ్లమ్స్ కనుక దీనిలో ప్రాక్టీస్ కనుక చేస్తే, దెన్ దీస్ ఆల్ ద జంక్షన్ లాస్, ద కిర్చాఫ్స్ లాస్ విల్ బికమ్ వెరీ ఈజీ ఫర్ యూ. చాలా ఈజీ అయిపోతాయి. దాని గురించి అంత టెన్షన్ పడాల్సిన అవసరం అంటే ఏమీ ఉండదు. ఈ కిర్చాఫ్స్ లాస్ యొక్క ప్రాబ్లమ్స్ అన్నీ కూడా మనము నెక్స్ట్ వీడియోలో మనం చూద్దాం. ఈ వీడియోని నేను క్లోజ్ చేస్తాను. హ్యావ్ ఆల్ ది బెస్ట్. థ్యాంక్ యూ ఫర్ వాచింగ్ ది వీడియో.